Okay, so let us start. So, good evening, everyone. So, this is Koushani Roy, and I'm the engineering mathematics faculty of Biotechnica. And usually, I teach the students preparing for this GATE, NET, and these types of competitive exams. Okay, so today we have the topic like matrices and determinants, which is the first topic of like whenever you are preparing for GATE. So this is the first topic for engineering mathematics from GATE. So we will be starting with this topic, and as well as you can ask me your questions, your doubts, whatever you are having, because I'm having my mobile with me. So I'll be like reading your questions and then answering you over here. Okay, so let us get started. Okay, so matrices and determinants. So first of all, we have to know what is a matrix. So now, matrices are basically some elements. You can say some numbers, some alphabets, some elements, some vectors, scalars. That can be anything. If we take the elements, if we arrange them in an array, then it is called a matrix. So a matrix is basically an arrangement of elements throughout a row, throughout some rows, and throughout some columns. So here we have like listed out a few. Okay, Sanjana is here saying that, ma'am, I have no mathematical background in degree. Yeah, actually, the thing is, that's why we have studied. I mean, started from here because the concepts that we will be discussing today, that is basically the concepts of higher secondary of mathematics. But those who didn't have the mathematics as the subject in higher secondary, for them it becomes very much tough to like start the subject from uh, middle. So we have to know like from beginning that what are the subjects and all these things. Okay, okay, so let us go on. So these are a few like uses of matrices. The matrix notation and the operations are used in the electronic spreadsheet programs for personal computer, which in turn is used in different areas of business and science like budgeting, sales projection, cost estimation, analyzing results. So basically matrix gives you a better representation of data. So whenever you are having some data, and if there are a lot of data, then we get confused, or there might be some sort of like uh, we there might be some error in like counting the data, or like accumulating the data. So those things can be sorted out with the help of matrix, because matrix gives you a better visualization or better representation of data. So matrix is basically, we can say, array of numbers or elements. The elements can be numbers, alphabets, whatever. Okay, matrices are also used in cryptography. This mathematical tool is not only used in certain branches of sciences but also in genetics, economics, sociology, modern psychology, and industrial management. So, matrix is something which has like its uses in various fields of studies. Okay, so matrix is not only bound in maths only. So here is how we can represent a matrix. So whenever we are having a bunch of data, is this a cover part question of net? Okay, so the thing is, in net, like in CSIR net, you'll be having questions on matrix, but that will be of higher level. So if you are not clear with the basic parts, then it will be tough for you to go for the higher level, right? So first we have to get clear with the basic parts, which we will be discussing today. So once you are clear with all the basics, then you can easily go for the higher level part. Okay, so yes, good evening. Okay, so let us go with matrix representation. So how we can write or represent a matrix. So here I have taken one example. Let me not just read out all the things. Let me just explain it to you. Okay. So Radha is a girl and she is having 15 notebooks, 6 pens, Fauzia is another one who is having 10 netbooks and 2 pens. Simran is another one who is having 13 notebooks and 5 pens. Now, so all these things can be arranged in like in a tabular format, which can form a matrix. Okay, so say here we are writing the names of the persons who are having all these elements, and here we are writing the elements that they are having, so notebooks and pens. Now, if we are trying to find out the number of notebooks that Radha owns, it's 15. So we will be writing 15 at the row of Radha and column of notebook. So that is how a matrix is formed. Now you can ask me that can we write this notebook and pens over here and then Radha, Fauzia, Simran, the names over here? Yes, you absolutely can. So this is the representation that we did here, right? 15, 6, 10, 2, 13, 5, and next 15, 6, 10, 2, 13, 5. So if we are just interchanging, if we are just swapping the rows and the columns, then we can easily write it like this. Okay, so it depends on how you are trying to represent the data. I mean, what you are trying to keep in the row section and what you are trying to keep in the column section. Do we need matrix and CSIR? Yeah, actually, in CSIR, matrix is there, but the higher level application of matrices are there, like the rank, correlate. I mean, not correlation, rank, eigenvalues, eigenvectors. These are there in the CSIR. But to know about those things, we have to first know about the basics of matrices. Okay. Okay, so let us come to the definition of matrix. So, matrix is basically a rectangular array of numbers or functions that are presented in a particular order. So, matrix will always have a particular order. So, what is the order of a matrix? Now, order of a matrix means the number of rows and the number of columns a matrix is having. So, how do we write this order of matrix? So, if we're having a matrix, then we can just write the rows and then the columns to represent the orders of this matrix. Okay. Okay, so let us do one thing. So, see how we can define that what are the rows and what are the columns of a matrix. So, rows are those arrays which are arranged horizontally, and columns are those arrays which are arranged vertically. Okay. Now, if we can see over here, see this is something which is horizontal, this is something which is which is horizontal, and so there are two horizontal lines and three vertical lines, right? So we can write it like 2 cross 3. Yes, hello. We can write it like so 2 cross 3. So similarly, if we're like coming here, so there are two horizontal lines, two vertical lines, like two horizontal arrays and two vertical arrays. We can write it like 2 cross 2. Similarly, what will be the order of this matrix? This would be, there are three arrays if we are checking it horizontally, and one array if we are checking it vertically. So the order will be 3 cross 1. Similarly, we can find the order of this as this, and the order of this as this, and the order of this as this. Okay, so that is how we can find out the order of the matrices. So now see, let me just change it to a pen. Where did it go? Yeah. Okay. Now let us come to this matrix. Okay. So whenever we are doing this matrix, see, all these are the rows of the matrices. All these are the rows of the matrices, and these are the columns of the matrices. Okay, first of all, please let me know. I'm just like looking over the chat section. Please let me know if you're having any doubt with the order of the matrices. Okay. Please let me know if you're having any doubt. I'm waiting. Okay, so I hope like everyone is clear with the concept of orders of a matrix, right? So clear, great. So let us just move forward with the concept of like order, more like order of a matrix. So let us go like see, here we are having like m rows and here we are having like n columns, right? Now see how to decide that what are the rows and what are the columns. So horizontally we are getting 1 2 3 4 like this. So m number of rows are here, and if we are checking vertically, so there are 1 2 3 4 5, like this is going on up to n. So n is the column number over here. So the order of the matrix is m cross n. Okay, and this is the generalized representation of this matrix. Now let us move forward. Okay, now this is something very much interesting. So the element at the ith row, so I here represents any row, and j represents any column. Okay. Okay, if I have to create one 2D array of 3 cross 3 order, at that time how many array will be created? Uh, what do you mean by 2D array of 3 cross 3 order? Because if we are having a matrix of 3 cross 3 order, then it means that it is having like, okay, two-dimensional array of 3 cross 3 order. Yes, at that time, how many arrays will be created? So, see, there are like 3 cross 3, you are saying it. So, there will be total 9 arrays because no, there will be total 6 arrays. So, like 1 2 3, that is the first row, second row, third row, and first column, second column, third column. This is a very good question. It's Shudipta Ghosh. This is a very good question. So if we are having like a two-dimensional array of 3 cross 3 order, then it will be like first row, second row, third row, then first column, second column, third column. So it means that there will be total 6 arrays. Okay. Okay. Now let us move forward. Please let me know if you are having any question. That is great. Okay, so let us move forward. So now a matrix of order m cross n is looking like this. Next, the element at the ith row and the jth column is represented as aij, and the corresponding matrix of m rows and n columns is represented as this aij m cross n. Now this aij means the element of ith row and jth column. So if I am saying I want to know about the element of seventh row and eighth column, so we will be trying to find out A78. Okay. So similarly, say if I have to find out the like, if we just a minute. So if we have to yeah, find out the element at the 10th row and say 12th column, so the element will be a 10 12. Okay, so now see, if a matrix is of order m and n, then the number of elements in the matrix will be m cross n. Now let us come to this point. See, the order of the matrix we have found out, it is 3 cross 2. Now what is the number of elements in the matrix? So it is 1 2 3 5 4 5 6. There are 6 elements, so 3 cross 2 is 6. Next, 1 0 0 1. So there are 4 elements, so 2 cross 2 equals to 4. Next, 5 7 3 minus 3. So there are 3 elements, so we are doing it 3 cross 1. Okay. Okay, so let us come to say this matrix. So there are, the order is 3 cross 3, so the result is 9, and this, there are total 9 elements in the matrix. So that is how we can count the number of elements present in a matrix. So now there's a like practice problem, we can say, to construct a matrix with two rows and three columns with the formula this, with this particular formula. So how we can construct a matrix with this particular formula with two rows and three columns? Okay, so let us see that what will be this matrix. So let me just open my whiteboard so that no, discard it, so that we can just go over there and we can do the calculation and all. Yep. So what is the equation that is saying? The equation that we got is aij equals to half of modulus of I plus 2j. So let us write it down over here. So we have got aij equals to half of modulus of I plus 2j, I think, right? I plus 2j, yeah. Let me just make it a bit bigger. Yeah. So I plus 2j. Now, how to, acha, so there's an order of the matrix is given. So there will be two rows and three columns. So the order that we are looking for, that will be 2 cross 3. Right. So let us just write a matrix which is of order 2 cross 3. Say this is of order 2 cross 3. Now, the order of the matrix 2 cross 3, it means that there are two rows. So number one row, say this is number one, so, and say this is number two row. And there will be three columns. So say this is column number one, this is, there will be column number two, and here we can write column number three. Now let us come to this point. So first of all, we have to find out the location of the element that we are looking for. So this element is at the position of first row and first column. So this element is at the intersection of, or we can say at the crossing of first row and the first column. So how can we find this element? So for this element, okay, let me do one thing. All these values are of I. These are I values and these are J values. Okay. So so say I'm trying to find out the element over here. So it is having first row and first column. So I value here is 1 and J value is also 1. So if we can just simplify it, so it will be half of I plus 2 multiplied with J. That is, next here the I value is 1 and the J value is 2. So here the element will be half of I plus 2 multiplied with 2, that is 4. Here the element will be, just a minute. Here the element will be in the first row and third column. So I is 1, J is 3. So it is half of I plus 2 multiplied with 3. So similarly, we can find out this also, that will be 2 plus 2, and this will be half of, say, I plus 2j, right? So I plus 2j, and this will be half of, uh, okay, I have written it, yeah, 1. So this will be I plus 2j. So what is the final matrix that we are getting? So this is 2 plus 1 is 3. So it's 3 by 2. Next, this is 4 plus 1 is 5. So 5 by 2. Next, it is 3 to the 6 plus 7 by 2. Next, here we are getting 4 by 2, that is 2. 4 plus 2 by 2, that is 6 by 2, that is 3. And next 6 plus 2 by 2, that is 8 by 2, so 4. So this is the final matrix that we are getting from this given formula. Okay. So whenever we are having this I and J and we are having an equation, we can just like replace the I and J values to find out the final matrix. Okay. Okay. So let us proceed. Please let me know in the comment section if you are having any doubt. Let me just check the comment once again. Please let me know if you are having any like questions. Okay, let me just go on. Then we will be like getting questions. Okay, so next let us go to the next slide, which is clear map. Great, great, great. Okay, so let us come to the next point. So different types of matrices. So here we will be learning about different types of or different kinds of matrices. So first that we will be learning is square matrix. Okay, where's the cursor? I cannot find it. Okay, so yeah. So first comes square matrix. Now, as the name suggests, so square means we will be having the same length of sides, like on each side will be of same length. So whenever we are having a matrix that is having the same number of rows and columns, then we can say that it is a square matrix because the length here equals to the length here. If we are counting the number of elements as the length, then here it is 3 and here also it is 3. So this can be considered as the square matrix. Next, let us come to row matrix. So a matrix will be called row matrix if the matrix is only having one row, nothing else. So if the matrix is only having just one row and no other thing else, so that can be considered as a row matrix. Okay. Okay. Next, let us come to this column matrix. So, what is a column matrix? So, column matrix is basically a matrix where there will be only one column, nothing else. So, row number of rows can be like 50, 60, 10, 12, whatever. But column will be only one. That type of matrices are called the column matrix. Okay, so these type of matrices are called column matrix. Now let us come here. Okay, so next comes with us diagonal matrix. Now we know the meaning of diagonal, right? So what is the diagonal? So diagonal is something that goes from the first first vertex of a square or of a quadrilateral to the third vertex of a, like the opposite vertex are connected through a straight line, and that straight line is called a diagonal of that quadrilateral or square or whatever like we are getting. So diagonal matrix means if the elements of throughout the diagonal of this matrix considered as a square is non-zero, then the matrix is called diagonal matrix. So a square matrix where all the elements in the main diagonal are non-zero. Okay, so here we have to keep in mind that it should be the main diagonal. Now what is a main diagonal? A main diagonal is something that is going from my side, that is going left upper to right lower. That is called the main diagonal, or we can say which is going like coming in the right down. So that is the main diagonal, and this is the minor diagonal, and this is the major diagonal. So whenever we are getting all these diagonal elements as non-zero, but the other elements are zero, then we can consider that matrix as the diagonal matrix. Okay. Now let us come to next, which is scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. So here the diagonal elements were different, and here we are having the same elements as the diagonal elements, like the same elements are there throughout the diagonal. So this matrix will be called a scalar matrix. Next, let us come to this identity matrix. A diagonal matrix where all the non-zero elements are 1 is called an identity matrix. So another property of it is when this, okay, so we will come to another property. So first, identity matrix is something where all the diagonal elements uh, have to be 1. So that is called an identity matrix. Next, uh, so another property of this identity matrix is there, that is identity matrix is something uh, if we are multiplying like this matrix with any other matrix, then identity matrix keeps the other matrix exactly same. So here we can use the concept of identities. So what are multiplicative identities? So multiplicative identity is something which when multiplied to any number, it uh, just does not change that number, it just keeps the number same. So 1 is the multiplicative identity because 1 is something which keeps the other number exactly intact, same. So when we are adding something up, so the additive inverse is 0, because 0 is something when it is added to any number, then it does not change the number. The number remains same. So similarly, if we are multiplying a matrix to any matrix and the second one is keeping the first one exactly same, then the second one will be called the identity matrix. So that for how what happens for with the identity matrix. Next, zero matrix. So the name says itself. So a zero matrix is a matrix which is having all the elements zero. Okay, it can be of order 1 cross 1, it can be of order 2 cross 2, it can be of order 2 cross 3, it can be of order 1 cross 2, anything. So if all of the elements are zero, then we can say it is a zero matrix. Okay, next let us come to the equality of matrices. So equality of matrices, if two matrices A and B are equal, then the position wise corresponding elements of them are also equal. So if we are saying that this matrix is equals to this matrix, okay, so we have to keep it in mind that whenever we are like equating two matrices, we have the both the matrices have to be of same order. Okay, because if both the matrices are of different order, then we cannot equate it. So to make the matrices equal, or the matrices will only be equal if they are having the same order. Now see, in this matrix, this is a 2 cross 2 matrix, okay, because there are two rows and two columns. This is also a 2 cross 2 matrix because there are two rows and two columns. So basically the order of this matrix is same as the order of this matrix, right? So these two will be equal only if they are having the same elements in the same location. So this A should be equals to this 5, this B should be equals to this minus 2, this C should be equals to this 3, and D should be minus 9. So this is what we are getting. Okay, now let us have a practice problem. Find the values of A, B, C, and D from the following equation. So there are two matrices given, both are equal, and we have to find the values of A and B. So let me just paste the problem in the whiteboard and let me just solve it out. Okay, so this was the problem, and we have to solve it to find out. Okay, so let us find out the values now. As we have just studied that if two matrices are equal, then the position wise elements are also equal, right? So we can write it just like, yeah, so say position wise this element is equals to this element, right? So we can write down, just a minute, we can write it as 2a plus b equals to 4, because this element is equals to this. Next, this element is equals to this element position wise, so we can write a minus 2b equals to minus 3. Next, this element should be equals to this element, so we can write it as this equals to 11. And what is the next equation that we are getting? 4c plus 3d, sorry, 4c plus 3d equals to 24. Now we can apply any of the methods of substitution or elimination or cross multiplication, whatever the method we can use. So what are the methods that we can use? First of all, we can use substitution. Next, we can use elimination. Next, we can use cross multiplication. Okay, so these are the three procedures that we can follow for now. I will be following the process of elimination because it seems to me very much easier than the other two process. Okay, so let me use the elimination. So how does this elimination thing works? So 2a plus b equals to 4. So we just have to make similar coefficients of any one variable and we can just cancel it out. So here we can multiply 2 to this equation. Say this is equation 1, this is equation 2. We are just numbering the equation. This is equation 3 and this is equation 4. Okay, now if we are we have to make the coefficient similar, so we can multiply 2 to this number 1 equation. So what this equation becomes, it becomes 4a plus 2b equals to 8. Okay, now if we write this equation, it's a minus 2b equals to minus 3. Now if we are adding them up, so 2b and 2b gets cancelled. So what is remaining? So 5a equals to 8 minus 3 is also 5. So a equals to 1. Okay, let us come to the next point. So a has become 1. Now if we are like substituting this value in this equation, what are we getting? So using equation 2, so using equation 2, what we can do is a equals to 1 will be substituted here. So we are getting 1 minus 2b, sorry, equals to minus 3. So what we are getting is minus 2b equals to minus 3 minus 1. So minus 2b equals to minus 4 and b equals to 2. So the value of b we have got as 2. Now let us come to this point. So here we are having like 5c minus d equals to 11 and 4c plus 3d equals to 24. Now if we multiply this equation with 3, then 3d and 3d, so both the equations will be having same coefficients for d, right? So let us multiply 3 with 3. So if we multiply 3 with 3, that then this equation will become 15c minus 3d equals to 33, and this will become like 4c plus 3d equals to 24. Now if we are adding them up, what is the value that we are getting? These are getting cancelled and this will become 19c equals to 7 5. So c will be 57 by 19, that is 3. So c is taking 3 value. Now put this c in any of this equation. Let me put it over here. So what are we getting? So 4 multiplied to c, that is 3 for us, plus 3d equals to 24. So 3 fours are 12 plus 3d equals to 24. Okay, so this is d. Okay, next 3d equals to 24 minus 12, that is 12. So d becomes 12 by 3, that is 4. So we have got the values of a, b, c, d, like a equals to 1, b equals to 2, c equals to 3 and d equals to 4. So these are the values that we have got. Okay, so this is like solving a problem where the similarity of matrices is used. Okay, let us get back to this. Okay, next, so addition and subtraction of matrices. So addition and subtraction of matrices is quite a very easy thing. So only two matrices of same order can only be added. or two matrices of same order can only be subtracted. Because if two matrices are not having like same order, then we cannot do the addition and subtraction. Okay, let us like understand it with an example. Say I am having one matrix, just a minute. See, I am having one matrix of order 3 cross 2. So if as it's a matrix of order 3 cross 2, so it means it will be having like 3 rows and 2 columns, and let us try to add it with a matrix of order 2 cross 2. So if we are adding this, say 1 5 8 and minus 6 0 7, and here we will be writing 2 cross 2, so 4 9 3 7. Now if we are trying to add them, then say you are adding this with this, so element wise addition. We are adding this with this, element wise addition. This with this with this. Then what to do with this? Nothing. So that's why matrix addition has to be with the matrices of same order. Now let us take two matrices of same order. Say the order is 3 cross 2. Okay. Now say I'm taking 3 minus 1 4 7 2 8. So this will become 4 minus 2. Say I'm just taking it from just my mind, nothing like nothing to make it tough. So 0 5 minus 2 7. So if we are adding these matrices up, then we will be getting a matrix of same order. Okay, and how we are adding the things, so the addition will also be done position wise. So 3 will be added with this 4. So what are we getting? So it will be 7, then minus 1 minus 2 is minus 3, then 4 plus 0 is 4, then 7 plus 5 is 12, then 2 plus minus 2, that is 2 minus 2, so 0, then 8 plus 7 is 15. Okay, so this is the resultant matrix, and similar thing happen whenever we are subtracting. So let us just like take the same matrices. Let me say these are the same matrices, and we are just taking a subtraction. So the element wise subtraction will be done. So how can we do that? First, 3 minus 4 is minus 1, then minus 1, minus 1, minus of minus 2. So that will be minus 1 plus 2, so that will be 1. Here 4 minus 0 is 4. Here 7 minus 5 will be 2. Here 2 minus minus 2, that is 2. 2, this 2 minus minus 2. So that will be 2 plus 2. So that will be 4. Next 8 minus 7, that is 1. So this will be the result of the subtraction. Okay. So that is how we find out the subtracted value or the difference of two matrices. Now let us get back over here again. Okay, so here I just have explained like the subtraction of matrices. Now there I have like provided one practice problems. We can solve it over here. Okay, let us just do it over here. Okay, sorry. Yeah. So it is given that x plus y equals to this 5209, and x minus y is this. Now say I'm considering this one as equation 1 and this one as equation 2. Okay. Now if we add them up, what are we getting? So adding 1 and 2, what are we getting? So we will be in the left hand side of the equality, we will be getting x plus x, so it will be 2x but plus y and minus y, they get cancelled. So it's 2x equals to 5209 plus 360 minus 1. So 360 minus 1. So what will be the result? It will be 8, 8, 0 and 8 again. So 2x is this. So what will be x? Now x will be half of this. So here comes the concept of scalar multiplication of matrix. We have to remember whenever a scalar term is multiplied with a matrix, then it has to be multiplied with all the elements of the matrix. So say I am doing like 2 multiplied with the matrix 5401. So it means that 2 has to be multiplied with all the elements of 5, like this matrix. So it should be 10, 8, 0, 2. So it should be like this. Okay. So similarly, if we are multiplying this half with all the elements of this matrix, so it will be like 4, 4, 0, 4, like this. So our x matrix is this. Now substitute this x is in any of the equations and we can find out y. So let us put this x in this equation. Okay, so x plus y equals to this. So from this equation we are getting y equals to 5209 minus x, that is 5209 minus this x matrix, that is 4404. Now if we are subtracting, what are we getting? 5, 4 is subtracted from 5. Okay, y multiplied with 2, 3. I think you're talking about the previous one. Okay, so let us do 5 minus 4 is 1, then 2 minus 4 is minus 2, next 0 minus 0 is 0, 9 minus 4 is 5. Okay, so this is the final value of y we are getting. This is the x that we got. Okay, so that is how you can like do the addition and subtraction of matrices. So there are I mean uh, a lot more applications of this addition subtraction of matrices are there. So we can easily talk about this after, like after this, whenever there will be a session we can discuss about those. So that was all for today. We just we just learned about the matrix representations, type definitions, order of the matrix, the types of the matrix, and then the addition and the subtraction of matrix. Okay, so hope you have understood all the things, but if you're having any doubt, then please let me know in the comment section. Let me just have a look over here. Okay, so till now there's no question. So I hope that you have understood the whole topic. And if you're having any doubt, please reach out to Biotechnica, and we will be like trying our best to help you out. Okay, so that was all for today's session. So let me just conclude the session. Just a minute. Discard. Yeah.